Okay. In salt hydrolysis, you need to be able to determine the pH of salt solutions in water. Okay, so yeah, depending on how the salt is made, you can calculate, you can predict the pH of a salt solution in water. Usually it's based on usually the pH will not be neutral if it contains like a conjugate acid of a weak base or conjugate base of a weak acid. Okay, and one more special case will be when the cation has a very high charge density. Okay, that's for salt hydrolysis. And acid-base titration, you need to be able to sketch the titration curves. Titration curve of the 4 types of titration. So this 4 types means it's just like strong acid, strong base, weak acid, weak base, weak acid, strong base, and strong acid, weak base. Okay. So in the titration curve, you need to show a few features. Okay. One will be the pH at start and end. Okay. Secondly, you need to know the equivalence point. And the pH at equivalence point. So this pH at equivalence point will link to the salt hydrolysis, because at equivalence point you only have the salt of your acid and base, because both are fully neutralized. Okay, so the pH will depend on what type of salt is formed or what type of titration you are doing. Okay, so the third one, you need to buffer region, okay, if any. Okay, yeah, these 3 things. So for indicators, you also need to teach the students where will the pH be equal to pKa, or where will the pOH be equal to pKb. Okay, that's the 4th one. For indicators, you need to explain how indicators work. So this one involves explaining the indicator is a weak acid. There will be an equilibrium, and like one color is different from the other and stuff like that. And you need to be able to choose suitable indicators for certain type of acid base reactions or titrations. Okay. Okay. Then the pH range. So each indicator, later you will realize that each indicator will have a pH range. So this pH range of indicators, and how this pH range is dependent on the pKa value of indicators. Okay, so that's all for acids and bases.